practice problems video for the fundamental theorem of calculus part 1. Okay, for this problem we're going to evaluate using that FTC1 the integral from 3 to 0 of 2t cubed minus 6t squared dt. Okay, so here there are actually two ways to do this, and I'll show you both ways. So the first thing we're going to do is, the first method is just leaving it as it is and integrating as we see it. Okay, so ideally what we want is to find that antiderivative and then evaluate it from 3 to 0. Okay, so the first thing we could do here is break it up according to this subtraction sign. So we have two separate integrals now. So integral of 2t cubed dt from 3 to 0 minus from 3 to 0 6t squared dt. So now we can move those coefficients outside, right? The 2 and the 6 respectively. So when we do that, then we can get a 2 times the integral from 3 to 0 t cubed dt, and then minus 6 integral from 3 to 0 of t squared dt. So this gives us, according to the power rule, 2 times t to the 4th with a 1 over 4 in front, evaluated from 3 to 0, minus 6, and then we have, here we have t to the 3rd, because we added 1 to the power, and then also evaluated from 3 to 0. Okay, so when we do that, then we'll get that we can simplify some things. So that's a 1/2, and this one is a 2 in front. So we have basically a 1/2 t to the 4th evaluated from 3 to 0 minus a 2 times t to the 3rd evaluated from 3 to 0. So at this point, see how we can actually just merge these back together because we're evaluating them from the same limits, right? From the same lower limit to the same upper limit, 3 to 0. So what we'll do is just write it all as one thing. So 1/2 t to the 4th minus 2 t to the 3rd, all evaluated from 3 to 0. So I'll do this on the next slide. So we have this 1/2 t to the 4th minus a 2 times t to the 3rd, and this is being evaluated from t equals 3 to t equals 0. So if we do that, we're going to plug in the upper limit first, so this 0. So we have 1/2 times 0 to the 4th minus 2 times 0 to the 3rd. So that's when we plugged in 0 into our antiderivative, capital F. So this is going to be minus when we plug in the lower limit. So this will be a 1/2 3 to the 4th minus 2 times 3 to the 3rd. Okay? So when we get that, this is all a 0, right? So we get 0 is 0 minus, and then 3 to the 4th is an 81, so that's 81 over 2. Okay, and then minus, I'm going to keep it in parentheses for now. 3 to the 3rd is a 27, so times 2 is a 54. Okay, so then we get 0, so minus an 81 over 2, and then minus this is a 108 over 2. Okay, so this is going to equal negative of negative 27 over 2, so this is going to turn out to be a positive 27 over 2. Okay, so that was the first method. Remember, we just started solving the way that the problem was presented. Okay, so this is the first method. That is our answer. And now let's embark on the second method. So if we look again, this is the original problem. So we're integrating from 3 to 0 of 2t to the 3rd minus 6t squared, and then dt. Okay, so here I want you to note that well, let's look at the limits of integration. So we actually have that 3 is our lower limit and 0 is our upper limit. So technically, 3 is not less than 0. So mathematically, this doesn't really work. But anyway, so what we can do first of all is actually reverse the limits of integration. Remember, so if we flip the limits, if we say 0 to 3, what we have to do is stick a negative sign in front. Okay? So now let's continue solving the problem and see what happens. Okay, so if we have something like that, and we continue on, we're going to get that this is equal to negative of, and then let's just integrate all in one go. So we have a 2, and then t to the 4th, 1 over 4, and then minus 6 just stays in front, and then we have a t cubed, and then 1 over 3, and we're just going to integrate from 0 to 3 now with this negative sign in front. Okay, so then this turns into negative of t to the 4th over 2, or like 1/2 in front, right? Minus 2t to the 3rd, and then this is from 0 to 3, all right? And then now that we have that, we can just plug in the 3 and then plug in the 0. So negative of 3 to the 4th over 2 minus 2 times 3 to the 3rd. And then this is minus, okay, that comes from the fundamental theorem of calculus, right? Minus a minus, this is from the formula, so minus another minus is not really going to matter because we're going to plug in 0 anyways, but I just want to stress that. So 2 times 0 to the 3rd, So all of this turns into 0, and this term here, let's work with that on the last slide. So we have a negative 3 to the 4th over 2, and then minus a 2 times 3 to the 3rd. Okay, so we have something like that. All right, and then if we factor, well, we're just going to simplify. So this is negative 81 over 2, and if we factor this negative in, we get plus a 54. Okay, so this is going to be negative 81 over 2 plus that 108 over 2, which is equal to a positive 27 over 2. Okay, so we get the same answer, but on this one we just reverse the limits of integration first to get it in actually like mathematically correct form. Okay, so that's our answer to the first problem.